sometimes you're going to encounter arguments that have phrases like the ones on your screen included in them. Phrases like, it is false that, it is not the case that, it is not true that, okay? And then what follows the phrase will be a premise or a conclusion, and that can make arguments tricky to deal with. So in this lecture, I'm going to cover a couple of strategies for contending with arguments that include phrases like these. So let's take a look at an argument. So here's an argument. No dogs are canines, therefore it is false that some dogs are canines. Okay, so my premise is offered as a true statement, and the conclusion is offered as a false statement. Okay, now what does that mean? It means this. It means that the claim of the conclusion is that because the premise, no dogs are canines, is a true statement, it has to be true that it's false that some dogs are canines. Okay? It has to be true that it's false. And that starts to get confusing, right? But think about it this way. This is all we're saying. I think the statement that you're swimming in the ocean right now is a false statement. Would you agree? Of course you would. Okay, that's a false statement. So it's true that it's false that you're swimming in the ocean right now. And that's kind of what this phrase means. When we say it's false that, we're saying it's true that it's false. And when that phrase appears in a conclusion, one way we can deal with it is by creating a Venn diagram, just like we would for any other argument. So we diagram our premise, no dogs are canines, by shading out area 2 to show that there are no dogs that are also canines. And then we ask ourselves this, does that diagram show that the statement some dogs are canines is false? And the answer is, yeah, it does. Because if the statement some dogs are canines was true, then there would be an X right here in area 2. But area 2 has been shaded out to show that the premise statement is true. And if it's shaded out, that means there's nothing there. There can't be an X there. That means that the conclusion statement, it's false that some dogs are canines, is a true statement. It's true that it's false. And this Venn diagram shows that. So the Venn diagram is showing that when the premise statement is assumed to be true, the conclusion, some dogs are canines, has to be false. It has to be true that it's false. And that shows that this argument is valid. Now take a look at this argument. Some mosquitoes are not lovable bugs. Therefore, it is false that some mosquitoes are lovable bugs. So again, we create our Venn diagram. We mark an X over here in area 1. That shows that some mosquitoes are not included in the lovable bugs category. And then we ask ourselves this, does this diagram show that it's false that some mosquitoes are lovable bugs? And the answer is no, it does not show that. There could be a mosquito right here in area 2. Maybe there is, maybe there isn't. We just don't know. So what that tells us is that the conclusion statement doesn't necessarily follow from the premise statement. It's possible, it could be false, that it's false that some mosquitoes are lovable bugs, okay? And that proves this argument invalid. Now take a look at this argument. This is trickier. It is false that no rap songs are works of art. Therefore, some rap songs are works of art. Okay, now what's tricky about this is that I know how to create a Venn diagram to illustrate what it looks like when a given premise is a true statement. But how do you create a Venn diagram to show what a statement looks like when it's being offered as false? How would you diagram this statement? I can't do it the same way I would when I assume a statement is true. This shows the statement, no rap songs are works of art, is true. But the premise of the argument is that that statement is false. So what do? Well, what you do is you say hello to your new friend. So here's another tool you get to put in your logic toolbox. It's called the modern square of opposition. And I'm going to explain here exactly how it works. So you see here on this square that you have each of the 4 standard form categorical statement forms, A, E, I, O. Okay? And what you can see is that the statements are connected horizontally and vertically with a dotted line, and they're connected at the corners with a solid line. And what this is sort of revealing to us is a particular relationship that exists between the statements at opposite corners, A statements and O statements, and E statements and I statements. And what this modern square of opposition is revealing to us is that when you have an A statement with a known truth value, the truth value of the corresponding O statement. In other words, when I say corresponding, a statement with the exact same subject and predicate terms, letter for letter. When you have A and O statements that have the exact same subject and predicate terms down to the letter, they have to have opposite truth values. So if you know that one of them is true, you know the other one is false. If you know that one of them is false, you know the other one is true. So if I give you, for example, the statement, all dogs are canines, that's an A statement, it's true. By the rule of contradiction, if I know all dogs are canines is true, I know the corresponding statement, some dogs are not canines, has to be false, because corresponding A and O statements have to have opposite truth values. Similarly, if I know a given I statement, like some dogs are cats, is false, then by the rule of contradiction, I know the corresponding E statement, no dogs are cats, has to be true, because the statements, corresponding statements at opposite corners of the modern square of opposition cannot have the same truth value. So what does that mean? It means that if it's false that no Phil 12 students are super smart people, by the rule of contradiction, it has to be true that some Phil 12 students are super smart people. Okay? It means that if it's not the case that all Phil 12 students are pizza lovers, that means that it has to be true that some Phil 12 students are not pizza lovers. Okay? It means that if it's not true that some Phil 12 students are rascals, then it has to be true that no Phil 12 students are rascals. Okay? So I can use this modern square of opposition to identify true statements when I'm given a false one. What does that mean? It means I come back to my original argument, and the premise says this: it is false that no rap songs are works of art. That's an E statement. And I know if that E statement is false, which is what the premise claims, then the corresponding I statement would have to be true, because by the rule of contradiction, corresponding E and I statements cannot have the same truth value. So if it's false that no rap songs are works of art, some rap songs are works of art has to be true. And now I have a premise that I know how to diagram. Okay? Now I have a premise that's easy to diagram. I just mark my X. And now I can see that that same Venn diagram also represents the conclusion statement. Okay, in fact, they're the same. The premise and the conclusion are the same. That tells me that this argument is actually valid. But it was much harder for me to see that when the premise included this phrase, it is false that no rap songs are works of art. So again, when I encounter this problem of having a statement in an argument that includes the phrase, it is false that, an effective way to deal with that is to just swap that false statement out for one that has to be true when that original statement is false. And you can do that by using the rule of contradiction.